Okay, so here, a retrofitted space heating system is being considered for a small office building. Okay, you want to install a new heating system. The system can be purchased and installed for 110,000. So that's the capital investment you want to pay for this new system. And it will save an estimated 300,000 kilowatt hours of electric power each year over a 6-year period. So the timeline is 6-year period. And every year you can save by using the new heating system, save how much? Save 300,000 kilowatts. But how much is that? Don't worry. So 1 kilowatt hour is 10 cents. Okay? So if you want to know how much you save, from using the new heating system, that is per year. That is what? That is 300,000 kilowatt hours times 0.10. Okay. See, this is the cost estimating, or the estimating method we have learned. It's a unit method. Remember that? Although this is saving, it's the same. Okay. So how much you can save every year? It is 3,000. Okay. All right. So let's continue to read the statement. And the company uses a MARR of 15% per year. Okay, you see MARR is always given. Okay, in its economic evaluations of refurbished systems. The market value of the system will be 8,000 at the end of 6 years. Okay, and additional annual operating and maintenance expenses are negligible. Okay, so you want to use the PW method to determine whether the system should be installed, if you want to accept that or not. So the first thing is you want to draw the cash flow diagram first. So you draw it from the office building's perspective. From the office's perspective, actually. Okay, because you're the office, so you want to install it, so you need to spend this 110,000. That's gonna be your first cash flow. So 0, 1, 2, 3, 4, 5, 6. Your first cash flow is outgoing. 110,000. Okay, and every year you can save 3,000. Remember that? So that's your receiving. It's going upward. Okay, so A is 3,000. And in the end of the 6 years, you can sell that system. Market value is 8,000. That's another receiving at the end. So it's another 8,000. All right. And your I% is MARR, which is 15%. Okay. So that's your cash flows. And then the same thing, you want to convert all of them back to the present time. So actually your question is, what is the present worth? It equals to P0. But what is that? You have multiple cash flows. You need to determine how many parts you need to do. So how many parts? you have a present investment, the first part. You have the annuities, the second part. You have the market value, the receiving in the future, the third part. Okay, so you do the same thing. You have P01, which is from the 110,000. It is the present value, okay? And you also have the part 2, which is from the annuity equals to 3,000, and it is annuity. Okay, and then you have the third part, which is from the 8,000 market value. It is a future value. Okay, and next you just want to convert these three parts back to the present. Okay, so back to the present, back to the present, convert back to the present. So P01, it is already happened at the beginning, so you don't have to convert anything. So the amount stays the same, but it is a negative amount. Again, the negative doesn't mean it's lower than 0. It means it's an expenditure. Okay, and the P02 is to find out P given A. So the equation is A times P/A MARR N. And A is 3,000. P/A, it's 15%, right? N is 6. So just check this. So P/A, again, this table is for I equals to 15. Okay, you always find out the table first, and then find out the column and the row. Number of years, 6. So this is your factor. So it is 3,000 times that 3.7845. Which is positive 11,353.5. Okay, this is the receiving, so it's positive. And part 3 is positive, and the equation is to find out P given F. So it's F times a factor P/F MARR and N. So it's positive. F is 8,000, and the factor is P/F 15%, 6. So positive 8,000 times the factor is P/F. Row is 6, so it's this. So it's 0.4323. It's positive what? 3,458.4. So now the P0 is the sum of these three parts. The first part is negative. Second part is positive. Third part is positive. Sorry, it's too thick. And the final result is 6,993.4. Okay, so the PW is P0 is 6,993.4, which is bigger than 0, which means this heating system should be installed. So you accept this proposal. Okay, so this problem is exactly the same as the previous one, except that at the first you need to calculate what is the annual saving. Okay, that's the only tricky part. But it's very real case, right? You're not always given all the values at the beginning.